So let's tackle the next problem here. Jump game 2. You're given zero indexed array of integers nums of length n, and you're initially positioned at the first index. Each element nums of I represents the maximum length of a forward jump from index I. In other words, if you are in index I, you can jump to any index I plus j, where j is less in the range of 0 to nums I, and I plus j is always less than n. So uh, yeah. So return the minimum number of jumps. So we need to return the minimum number of jumps to reach the index, the last index. So now it's given that you can always reach the index -1. We only need to return. So there are no, we're not given a situation where we cannot reach such the last index. So we will always be reaching the last index. We only need to find out what's the minimum number of jumps. So let's take the first example here, 2 3 1 1 4, and yeah. So jump game part 2. Jump game. So 2 3 1 1 4. So basically, let's say you took two. just- Let's just say you just took one step. Uh, and then from 3, if you took 3 steps, 1 2 3, you would reach the last one. So that would be 2 steps. Or if you were too dumb, let's say, and you took from 2 just the last one, and then from 1 you took another step, and then another step would be 3 steps. So which is not the best answer here, which is it's not the minimum answer. So basically, the way to think about this problem is that you imagine. So again, this is also greedy problem. So you're always looking at the best possible number at each step. So what you do is you basically need to imagine the divide problem into steps. So this is one step, and from this step, the next uh, region of steps that you can take, the region would be from here to here. So this is like, let's just say this is the zeroth step because you're already here. And with one step you can reach these two numbers, and with two steps you can reach these two numbers, two or more steps, because if you're dumb enough to come to 1 instead of 3, from 1 you go to 1 again, and then 4 again. This always know that this always represents, it always represents the minimum number of steps. So even if you took from 2 to 1, even if you took 1, I mean, even if you go from 2 to 1, and then from 1 to 1, and then 4, it doesn't matter, because here this region only keeps track of the minimum number of steps, because we're only striding, we're only taking strides in terms of these big steps. So with 2 steps you can reach this region, which means the last region can be reached in the minimum of 2 steps, and that's exactly what we need. So there's a way to do this problem, and basically we say that the minimum is so I mean, this does look like a window, doesn't it? So we just call it L and R. So as far as this one doesn't reach the n minus 1, we're good. So how we do is the farthest. So in each loop, the farthest at first would be, I mean, let's just say the farthest is 0. So 0. We have L and R in the range of L and R plus 1. Remember that both L and R are at 0. So in the range of R and L plus 1, it means exactly 2. What's the farthest? Farthest is we take the maximum. So farthest is always like the maximum of itself, farthest, and I plus nums I. So I plus nums of I, which is basically I is basically 2. Oh, sorry, I is 0, and in this case, nums of I is 2. So what's the maximum? So farthest will now become 2. So that. So that's what would happen. Farthest is now 2, and so L would now go to. Let me draw that again. So now L would go to R plus 1, but whatever it was the R plus 1, again, as far as R is less than that, R would be the farthest. So obviously, like we said before, R would always take the farthest, which was 2. So now the minimum number of jumps is this window plus 1. So we had 0, now it's 1. The next iteration, the only thing we increase is check again the loop. So check from 0 to check in this window exactly. In this window, what's the maximum that farthest can be? So here, farthest is 2, and what's the maximum of as well? And I is I is in the range of L and R plus 1. So 3, and nums of I is well, okay, I is actually 1. 1 plus nums of I is 3, so that would be 4. So farthest we can reach now is 4, and so farthest would be here, and L is just R plus 1, and R would be the farthest. So R is less than N minus 1, and maximum. So we had already, so we counted this one, and then we count 2 now. So in the next iteration, what happens is we come again. So in the range L and R plus 1, what's the max? What's the farthest again? So we take. Okay, so R is already now equal to N minus 1. So R, so we just will jump out of this loop, and we already got the maximum, the minimum number of jumps. So to get the Python code, def min jumps take nums, and we get null as length of nums, and we initialize min jumps to 0, L 0, 0, 4, 3, so while R is less than this 1, make sure we have to make sure of that. So we're always resetting the farthest to 0 here. I mean, so because we don't know how far we can reach every time for I in range of L to R plus 1. R plus 1 because the range function is, well, that is like exclusive, this is inclusive. And farthest is maximum of itself and I plus nums I. Why this is exactly the case? Because I is your position and nums I is how many steps you can take from this position. So maximum is just the farthest you can reach in that range, while making sure R is less than N minus 1. L becomes R plus 1 naturally. R becomes the farthest. And so every window, every area regions will do like this. Increment the max jumps by 1, ultimately turning, I mean min jumps, ultimately returning min jumps. So that's the code.